All right, so when we continue on with this, we can see that we can write the same formula, but in terms of if we're trying to find any of the other missing sides. So a triangle has A, B, and C typically as its sides. So what would the formula look like if, for instance, it started with A squared? So if it started with an A squared in the front, then the other two sides that aren't A, so in this case B and C, would then be added and squared. And then we would go subtract 2 and then repeat those two sides again that are on the interior, 2BC, times, right, cosine vertex A in this case, because the front and the back have to match. And likewise, we can rearrange it now for what if we started it with B squared equals. So if it started with B squared equals, then again, the other two sides that are not B, so in this case, A squared and C squared, minus 2 times A times C times cosine, in this case, vertex B, the angle that goes with little b. So these are not three different formulas. This is the same formula written three different ways, depending on which one of the three sides you're trying to solve for. So what happens is this formula now allows us to solve for angles and sides of certain triangles. So what triangles then would we actually use cosine law for? So cosine law is used in these two situations. The first one, so ABC, it's used when we have two sides and the angle in between those sides, so say 60 degrees. So if I know this side and I know that side, so I know little c and I know little b, and I know corner A, I know, in this case, little b, little c, and corner A, what that allows me to find is side length A. So we call this the side angle side situation, right? The two sides with the angle in between those two sides. So if you're given this situation, you can't use sine law because you don't have the angle opposite the 9, and you don't have the angle opposite the 7, and you don't have the side opposite the 60. You need a complete ratio, remember, in order to use sine law. The other situation where you have to use cosine law, and again ABC, is, okay, 7 and 9, say, are those side lengths, but say this one's 11. So now you know no angles, just three sides. What this now allows you to do in this situation, which we refer to as side, side, side situation, so three sides, no angle, is now you know this side, this side, this side, this number, but you don't know this number. So it allows you to rearrange the formula to get either one of the angles that's at the back of the formula, to get that by itself, isolate for it, so that you can find any one of the three missing angles. And then once you know a certain corner, you know the side that goes with that corner, that sets you up for sine law if you wanted to continue finding more things. So all three sides, which is the side, side, side situation, or two sides and the contained angle, that's the SAS situation. So these are the two situations where we must use cosine law. All right, so now let's actually see how we actually use it. So here we have a triangle. It says solve triangle, which means find everything that's missing. So because it's saying find everything that's missing, we first have to draw it. I don't even know what we have and what we need. So don't draw a 90-degree triangle. I'm not told it's 90 degrees. So just draw a basic triangle. It's not to scale, so it doesn't matter. It's called XYZ, so put an X somewhere, put the Y somewhere, and put the Z somewhere. Little x, so little x is across from capital X, and that's 7 centimeters. Little y would be across from capital Y, and that's 6 centimeters. And angle Z. Angle Z is right here, and it's 43 degrees. So that's what we're given in this situation. Now notice when we go through our thinking, we don't have a 90-degree angle, so we can't use SOHCAHTOA in this situation or Pythagorean theorem. It doesn't exist here. But we also don't have the angle that goes with the 6 or the angle that goes with the 7. And because we're missing too many angles, we can't use angle sum of a triangle to figure out any of the missing angles. So that means sine law is it's not an option anymore. So this means this has to be, because it's side angle side, right? Side angle side. It is a cosine law situation. So what we need to do is we need to set up cosine law, and we have little x, remember, we have little y, and we have z, angle z. So the only thing that cosine law is going to allow us to find is side length z, the z that's across from the angle that we know. So we're going to set up cosine law with x, y, and z's, but it's going to start z squared equals then the other two sides. It doesn't matter if you put the y before the x, it won't matter. X squared plus y squared minus 2 times the x number times the y number times cosine, because it is cosine law, so use cos, angle z, capital Z. So I know this number, I know this number, I know this number, I know this number, I know that number. So I know all the numbers I need in order to sub in to get little z. So z squared equals, let's fill it in. X is 7. I'm going to leave off the 0.0 in the centimeters. So 7 squared plus 6 squared, subtract 2 times 7 times 6 times cosine. You can put the times or the dot or leave it off if you want. 43 degrees. So I've inserted all the numbers. This is how I suggest you enter it into your calculator, because it actually makes it very easy and it's one step. I always tell my students to start at the back because that's the most complicated part. So start with cos 43. So go cos 43 equals. You get a decimal. Don't write it down. Then go times 6. You can press equals if you want. Times 7 times negative 2. So you go times and then the negative sign. So find your negative button. For some people it's down here on their calculator, the plus minus. But you want not just 2, regular 2, but negative 2. Some people do the 2 first, then the negative. So practice until you get to this answer, negative 61.4337109.4. Okay, so figure out how your calculator does it. I'll do it again. Cos 43 equals times 6 equals times 7 equals times negative 2 or 2 negative equals. So you should be looking at a negative number right now, negative 61.4337109. That's this whole back chunk. So we just did order of operations in our calculator where we answered the whole back answer. So now we have to add 6 squared, and then we have to add 7 squared to this. So I'm not going to write this down because we're not finished yet. So I'm going to go plus, because these are both pluses. If you have the square button, you can just go 7 squared plus 6 squared. Now if you don't have a square button, you could just go bracket. So after the plus sign, you can do open bracket, 6 times 6, close bracket equals. Now I know you probably know that's 36, but sometimes you're dealing with decimals and you don't know the answer to 6.7 times 6.7, right? So that allows you to have the calculator do it. And then after you press equals, you get this long number, 23.566. Don't clear your calculator. I'm going to write this down. Don't call it 23.6. It's 23.56628.906. Okay, so I wrote down all my decimal places. Now that is not how long this side is. This side is not 23.566, right? So we have to realize that this is z squared. I don't want z squared. I actually want z. So what we need to do is we need to square root both sides. So while it's all still sitting in your calculator and you haven't cleared it, go square root equals. Now we get a number that's more like what we were expecting, 4 point something. So the full number is 4.854512238. Now I wrote it all down because there's still more work to be done because I have to solve for everything. So this was 4 little z, right? That's what we just solved for in our first situation. So this side is 4.6 if we're rounding to 1 decimal place. But just in case I need to use this in my next calculation, I don't want to be calling it 4.6 because then technically it's not accurate. Step 2, now that I know this side, I can now try to find angle y or angle x. The order I find them in doesn't matter. But now I know an angle side combo. If I believe this answer is correct, then I know the angle that goes with that answer. So what that allows me to do is to now use sine law to find either of the other 2 corners because I know those other 2 sides that go with those 2 corners. So I'm going to say 4 angle x dot dot, right? I'm going to do angle x next because I just picked it. I'm going to set up sine law. So sine x over little x, I'm now going to compare it to sine z over little z. Sine angle x is what I'm trying to get here. Little x is 7.0. Sine z is 43. And little z, so this is where I don't want you calling it 5 or 4.9 because technically that's not accurate. 4.854512238. So if you really want to be accurate, you're going to use the full number. So in trigonometry, that's kind of important. So remember to isolate for what we're looking for. You're going to bring up to the other side. So you're going to get sine 43, right, times 7 divided by that 4.854512238. You can also just call it z and just put it in your calculator, but don't write it down. Once you get that answer, remember though that in order to get angle x by himself, you're going to have to inverse this. So you inverse all of that answer. So we have to get that answer first. So sine 43 equals times 7 equals divided by 4.854512238. This is an 8. That doesn't look like an 8. Okay, so I input all that into my calculator. I get 0.9834, and then I go second function sine. I inverse my sine to get 79.5 degrees. So angle x equals 79.5 degrees. 1 decimal place is usually good enough. So now that I know that this corner is 79.5, the last remaining thing is angle y. I'm not going to use sine law again to get angle y because I know this corner and I now know this corner. I'm just going to say angle y equals 180 minus 79.5 minus, what else do I know, 43. So 180 minus 79.5 minus 43. So that's 57.5 degrees. So what happens then, once you're done and you found the 3 missing parts, you summarize, and this is where now you round and you put units. So therefore, angle x is 79.5 degrees, angle y is 57.5 degrees, and little z is 4.9 centimeters. Okay, so let's check our triangle. So I'm saying that little z is 4.9, so I'm going to put 4.9 here, 79.5, and 57.5. Because I want you to always get into the habit of checking. Smallest angle, 43. Smallest side, 4.9. Biggest angle is this one. It's almost 80 degrees. Opposite the biggest side, yes. And the medium goes with the medium. And you can see because they're relatively close to each other, the sides are relatively close to each other. So it makes sense. It matches. All right, in the second situation here, it's asking us to find a missing angle. So find angle P. So I'm going to put a theta symbol there so we focus on that one. So remember, there's no 90 degrees, so there's no opposite adjacent hypotenuse, right? That doesn't exist here. So we just have to find this angle now to the nearest degree. Notice I'm given a side, and a side. So this one is little r, this one is little q, and this one is little p. I know those three numbers. So this is a side, side, side situation, right? Because I know the three sides. So what I'm going to have to do is I'm going to have to use cosine law, but I'm going to have to rearrange cosine law to get at the back of the formula where angle P is sitting. So that means, because I know little p, in order to get angle P to participate in the formula, because it has to be there in order for me to be able to solve for it, I have to set up cosine law with P squared in the front. I can't set it up with Q squared in the front or else I'll get a capital Q in the back. And I don't care about angle Q. I can't set up cosine law with R squared equals because that's going to give me capital R in the back and I don't want angle R. So I have to set up cosine law with P squared equals R squared plus Q squared, or Q squared plus R squared, minus 2 times R times Q, because now there's my cos P, right? Whatever's in the front matches whatever's in the back. So those match. Remember our pattern. But this is set up to solve for a lowercase side, right? The lowercase is the sides. But I know this number, 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 I don't know this number. So that means I have to rearrange this formula. So I'm going to show you how we rearrange it to isolate for for P, the angle, and then you can just memorize that, or you can just learn how to do it, and then you'll never have to memorize the other version of the formula. So the first thing you kick out to the other side is R squared and Q squared. They're going to cross the equal sign, and you're going to get P squared minus R squared minus Q squared. And what's that going to equal now on the other side? Whoever's left. Negative 2RQ. Cos capital P. So now I almost have it by itself. The negative 2 times R times Q. Remember that there's a times symbol in here, right? Those are all being multiplied with each other. So in order to get rid of it and move it to the other side, you have to do the opposite of multiplication. So this is not subtraction right here. That's not what it means. All of these numbers are being timesed with cos P. So to get rid of it, you have to divide out what you're trying to get rid of. I'm trying to get rid of the Q, I have to divide by Q. I'm trying to get rid of the R, I have to divide by R. And I'm trying to get rid of negative 2. So I divide by negative 2. And whatever you do to one side, you have to do the exact same thing to the other side. So what happens is the negative goes away, the 2 goes away, the R goes away, the Q goes away. And that leaves you with just cos angle P, which is what you wanted. You wanted angle P. On this side, what you're left with is P squared minus R squared minus Q squared, all divided by negative 2 times R times Q. And again, the two guys in the back here repeat on the bottom. That's the rearranged formula. So you can either memorize this, the pattern, or you can just know how to get to it. And then you'll never have to memorize it because you already know how to set it up from the beginning. So now that we have our rearranged formula, I'm going to sub in our sides. So little p is 11, so I'm going to go 11 squared, and it has to be in the front. These two can flip-flop, we don't care. R for me is 5, so minus q, which is 10, all over negative 2 times 5 times 10. And that's what cos p is going to be. So unless you're really good with your calculator, you can just figure out your top answer. So 11 times 11 minus 5 times 5 minus 10 times 10. So you can do it with brackets. 11 times 11 minus bracket 5 times 5, bracket minus bracket 10 times 10, close bracket, equals negative 4. That's your numerator. If you have the square, 11 squared minus 5 squared minus 10 squared. So both situations work. On the bottom, negative 2 times 5 times 10. We already know this answer is negative 100. So that equals cos p. So what we need to do is we need to divide this number by that number. But remember, that's cos p. I want angle p by himself. So in order to get angle p, remember that the cos now has to be kicked up to the other side. And with the cos on the other side, that's when we take the inverse. So you're inversing whatever 4 divided by 100 is, which is 0.04. However, if you don't even want to write that down, You could just keep it as a fraction and not write anything as far as a decimal down. Totally your choice. So 4 divided by 100 equals, so you could have written that part down instead. And again, a negative divided by negative is a positive. So we have 0.04 and then go shift cos. So not shift sine, this isn't sine law, this is cosine law. So you use cos. 87.7 degrees. Let me finish over here. Angle P is 87.7 degrees. To the nearest degree, angle P equals 88 degrees. There we go. So that's me following directions at the end. So I always go back and check to see, did it give me specific directions? So again, let's review what we did here. We noticed that we were given side, side, side as a situation, no angles. It gave us what corner to focus on. If it didn't and we got to pick, then you would have gotten to pick. Do you want to find angle P, angle Q, or angle R first? In this case, it only wanted P. So because it wanted P, I knew I needed a P in the back of the formula, which means the formula had to start with little p, right? Because that's what dictates who's in the front, who's in the back. I rearranged my basic cosine law by kicking out the two sides that are just sitting right here at the front. They become subtract, and I divide out the chunk that's attached to the cos, which is negative 2RQ in this case. So that's my rearranged formula. I subbed in my numbers from the diagram. And then separately I figured out my numerator, and separately I figured out my denominator. And then I divided those numbers and did my second function cos, shift cos, and that inverses in order to give me the angle by itself. So now that I know this is 88 degrees, I still don't know the other two corners, but if I needed to find the other two corners, again, like before, this now sets me up for sine law, if I believe in this 88 degrees number. Otherwise, what I could do is I could redo cosine law again, but this time, for instance, set it up with Q. And redo this formula, but start with Q squared equals R squared plus P squared. And pretend I don't know this 88 number, because what if this happened to be incorrect? Then I don't want to use the 88 in my next calculation, for instance, because if I use sine law, I'm going to have to use the 88 to go with the 11. I could just pretend that I'm starting the question all over again fresh and just use the 5, 10, and 11 numbers that I was given, but set up cosine law to start with Q squared. And that way I would get capital Q at the back. I would rearrange and isolate for angle Q. And that would give me this corner. And then I can use the 180 rule, for instance, or cosine law to find the last corner. That's if it asked me for those things. It didn't, so that means we get to stop right there. So practice, obviously, is going to be very important as you get more comfortable with this. All right, so hopefully that makes a lot of sense to you. Again, you need to do it for yourself. And ask me if you have any questions.